Hey guys, David here and welcome to another video. Here I have my RatRig KillerBee and it is working great. I've been using it for a few months now and I've done a bunch of projects and a bunch of testing on it. So after having done a full building series, I want to really give it a good review. So if you're thinking about getting a KillerBee, you'll know what did I choose, what options did I choose, and is it any good? So I'll split this up in two parts. This video is going to be all about the different options I chose, whether they were a good idea, and just kind of the physical build of it. In the next video, I'm going to go over the performance, what can it cut, how fast can it cut, all of that goodness. It's going to be a bunch of machining. I did a lot of different testing in aluminum, in woods, in plastics, all kind of stuff. So make sure that you subscribe so you don't miss that part when it comes out. For this video, I'm going to structure it with the different parts of the machine, starting off with a general overview, then going more in depth on all the different parts. I'll of course have timestamps down below. But before we get started, I need to pay some bills. This was not a cheap machine built, and one of the reasons why I was able to do it is sponsors like PCBWay. They make super high quality PCBs at a very affordable price that are great for prototyping. You can get 10 pieces up to 10 by 10 centimeters, double-sided with everything you would want for just $5. And in case you need some CNC services, for example, because you need one of the brackets that you don't already have to build your CNC, or you want some metal 3D printing, they also have manufacturing services that you can check out down below. So yes, speaking about paying bills, I paid out of pocket for this machine. RatRig did not send it over for free. However, since I've started making videos, I have been in contact with them, but no money has exchanged hands. Giving you a bit of an overview, if you have checked out the RatRig website before and think that this does not quite look what you saw there, that is correct. The base that I'm using is the 1075 machine, meaning it's 1 meter long by 75 centimeters wide. That's not the cutting area, but like the machine size. And I feel like this is the perfect middle ground. It's large enough so it does not restrict you in the projects that you can do, but it's also small enough to A, not take up a bunch of space, but B, also be still quite rigid. Once you start spanning larger distances here on the x-axis, you lose a lot of the rigidity of this machine, as the larger sizes do not have any extra beams. It's just the same setup, a bit longer. On this size for 75 centimeters, I feel like the dimensioning of the beams here is just about perfect. For the kinds of work that you would be doing on this machine, it's sturdy enough, it's very rigid, but at the same time, it is also not completely overbuilt. If you are, however, going to meter or even meter and a half, which they offer, cutting stuff like aluminum or any other metal is going to be a lot tougher, as there's just a lot more flex in the beams at that point, which will translate to worse cutting results. So I would suggest to go as big as you need, but as small as you can get away with. On the y-axis, you can get as large as you want. That does not really add any extra instability, that just gives you more travel and is in that way good. But I don't think they offer like a 75 by 1.5 meters, but I'm sure if you ask them, they could probably do that custom for you. I also chose not to get a lot of their options. You can basically build a full kit with all the electronics and everything on the RatRig website, and that is great if you're just getting started and you don't have super high demands for the electronics. If you just want to use a wood router on there, then feel free to go with something like the black box. I think it runs Gerbil, which means you can just hook it up to your laptop. It's fairly easy to control. No software that is super difficult to configure. Just easy way to get started. However, I wanted a bit more. I wanted to run Max 3 on it and have a bit more features, so I chose to do all the electronics separately. I'll show you them in a minute. And I also chose to go with closed-loop stepper motors instead of regular stepper motors. They still need my 2030, they just have an encoder on the back, which means that I can drive them a bit harder and be certain that the machine has actually executed the moves that I told it to. Then the next big obvious thing is there's an enclosure, and I knew from the beginning, having built another CNC before, that an enclosure was an absolute must. For one, machine is still quite loud. Cutting stuff is not a quiet operation, so having an enclosure is going to cut down on that. But mainly, it makes a lot of dust, especially if you're cutting wood and it's just dusty everywhere. And if you're cutting metal chips, having a vacuum, they just have so much velocity, they fly all over your room, and you're gonna spend as much time cleaning up as you spend machining, which is not fun. So knowing that I will want to build an enclosure and I wanted to use T-slot extrusion for that as well, I decided to just buy that from RatRig as well, since they are one of the cheapest suppliers around here, although they ship from abroad. And that meant I just did a fusion model of everything. They have a 3D model available of the machine. It's the smaller size, but it was easy enough to just kind of blow up to the one that I'm using. And that allowed me to get all the dimensions I need to make it as small as it can be without being too small that the machine wouldn't fit. To make it a bit narrower, also flipped around the X-axis motor, as by default it just kind of sticks out the back, which is fine if you have the machine freestanding, but in an enclosure it adds a lot of space that is not really necessary, especially since my motors are quite long, thanks to them being closed-loop stepper drivers that have the encoder on the back as well. So I just milled a little bracket that flips the motor around and uses a belt instead of direct coupling, which works perfectly fine and just makes the whole enclosure about 5 to 10 centimeters less deep, meaning I have more room in this room here. I also went ahead and built a very sturdy table. I made a separate video about that as well. And even though this frame is quite stiff, if you have a table that is just slightly bent, the frame will just conform to that table. It's not that stiff. And that means that then your cutting will also conform to that bend and you will have crooked parts. So having a table that is not just sturdy enough to support this rather heavy machine, but also quite nice and flat is very important. To control the machine, I already mentioned I'm using Mach 3, and that is running on a tablet computer here that is attached to my custom controller. I made a separate video about that as well. I just have a mechanical keyboard here with some buttons that interfaces with the tablet. And this allows me to control this machine as well as my other CNC mill from one convenient console. I also do have a handheld MPG controller, which is something I added to this machine that I did not have on my other mill. And get this, it's not that expensive. It's probably around $100, but it's the best $100 you'll ever spend on your machine. It's so convenient to just kind of look at your part and turn a hand wheel to get everything properly lined up, get your starting point, and you're gonna save so much time by having this instead of trying to jog it with some buttons on the screen. It's just a huge pain. But I've not mentioned it, is the Spindle. I'm using a 2.2 kilowatt air-cooled Chinese Spindle. It's nothing amazing, but it was decently cheap. Came with a VFD, and it allows me to get decent control between like 6,000 RPM and 23,000 RPM, and that means I can cut with small tools, but also slightly larger. I have good control. Everything is software controlled, and 2.2 kilowatt is more than enough power. It's actually almost a bit too big for this machine. 1.5 kilowatt will probably have been enough, and especially if you're going with a bigger machine, I would definitely recommend the slightly smaller size, as that will put less weight on the X-axis and cause for less bowing. The only disadvantage of getting with the smaller machine is that they usually have a smaller collet size, and I quite like this one. I believe it's ER16, not 100% sure, don't quote me on that. Just look up what a 2.2 kilowatt Spindle comes with. So that is kind of a rough overview, or a more detailed overview, as I now realize, but I'll get you a bit closer in, and then we can talk a bit more about the frame itself. The way that the KillerBee is configured is you have two C-beams that are running all the entire length, and attached to them are the linear rails for the y-axis. There are two rails on each side, which is quite nice. It's definitely one of the big reasons why I went with the KillerBee, is that it has linear rails on all the axes. And in the middle it is using a Acme screw, which is not the best option. Like a ball screw would obviously better, but a cheap ball screw versus a cheap Acme thread, I think I'll go with a cheap Acme thread, just because it is a lot easier to just adjust manually by having your nut spacer slightly adjusted, whereas if you have a bit of slop in a ball screw, there's not really anything you can do. The screw itself is 8 millimeters diameter, was 4-star, I think it's 8 millimeter pitch as well, and that is a good balance between being able to move the machine quick enough but still having enough resolution to do fine detail work. To get around the problem of such a long trapezoidal screw kind of whipping around, what they did is they have bearings on either side and are actually tensioning the screw. So it is under tension and secured on both ends, which means that it just whips a bit less. Now, still on like the 75 centimeters here on the x-axis, there's not really any issue. At 1 meter, you started to get to the point where the speed is limited not just by the motor, but also by the lead screw. I have it configured that the maximum travel speed is 5,000 millimeters a minute, which is still decently fast for a CNC, but definitely if you have a smaller one, then it would not be as important, but you could possibly go to maybe 7,000 with the same motors. But if you're using standard stepper motors, you will not go past 5,000 anyhow, probably staying closer to like 4,000 millimeters a minute anyhow. But if you are going with the 150 length, definitely keep that in mind that although you have a bigger machine, you're actually going to be probably traveling a bit slower, just because once these screws start whipping, you just all kinds of vibrations that are not good and no fun. So keep that also in mind when deciding on which size you're going to go with. One thing that is not stock, surprisingly, that I definitely highly recommend is that by default, there's just like a cross beam at the start and the end, which these C-beams are resting on, and then these cross beams are connected with some beams lengthwise. And that means that these ones are actually floating, the C-beams. I'm not sure why they did this. I tested it, put a dial indicator on it, and just kind of pushing on the beams here in the middle did make them move by like almost 0.2 millimeters. Now, I put on quite a bit of force on, but that means that if you're doing a lot of cutting operations in the middle of the table, the forces of your cut could potentially move this C-beam slightly. So what I did instead is to just put another beam underneath, another 2040 extrusion, the same length as all the other ones, costs $5 extra, and just means that now this is super solid as it is directly touching the table. And as long as your table is nice and flat, this will not create any issues. I also elected to go with an extra slat here in the middle. By default, it's just 3 slats lengthwise. I added an extra one here, so I have 4 slats here supporting the bed and 2 additional ones, one under each of the C-beams. For the bed, I took a page out of the book of the Shipoko 4 and went with some T-slot and some MDF strips in between. This means I can just replace individual MDF strips instead of having to replace all of them. And the idea is that I could use these clamps in here and clamp down my bigger work pieces like that. And this is a lot of clamping force and really easy to set up. However, I never really ended up using them as they are quite tall and quite bulky, meaning that you quickly run interference with parts of the machine itself. If you have a big old sheet and you can clamp down here and only work here, that is perfect. Like if you're doing some engraving work on a big wood piece, that works. But I ended up doing a lot of pieces where I basically wanted to machine everything, so these clamps I never really used. What I used instead is either just straight up double-sided tape for like large thin pieces, or otherwise I screw it directly into the MDF, which works quite well. However, I would love to get some Saunders Machine Works pallets and their Modvise system. That would be the absolute dream. And while it is quite expensive, it's not all that bad considering the flexibility it gives you, and that really allows you to just kind of clamp pieces any size beautifully and low profile. That's the other issue. I could just put a vise on here, but the clearance for everything is quite low. I mean, compared to some other routers, it's decent. I think there's around 12 centimeters of Z clearance, which I've seen routers that only had 6, so 12 centimeters is great. But most machinist vices, at least the one I have, is about 10 centimeters, giving me 2 centimeters to work with, and it also needs to include the tool stick out, so not gonna happen. But something like the Saunders Machine Works Modvises, they're only like 2 centimeters high, which would be great here. The only reason why I haven't gotten them yet is because they ship from the States and I live in Switzerland. So shipping and import fees would be as much as the plates themselves, so a few $100. But I still might upgrade to that at some point. If you haven't heard of them by any chance, we'll definitely put a link down below. They don't have one specifically for the KillerBee, but the ones for the Shipoko should work quite well on the KillerBee as well. The main other thing here that's somewhat frame related that I did not do stock is of course the mounting for the spindle. I did not really think that through in the beginning, but I ended up being that once I had the spindle here, these little corner brackets that I got to connect all the different parts of the enclosure were actually the perfect size to connect the spindle to the seat plate, to the side of it, and that works quite well. The only issue is that it kind of obstructs these slots that I was intending to use for some accessories, but I'll have to figure out something else for that. Right now, for the most part, I've just been using the spindle by itself. I did design a dust shoe for it, like this 3D printed part would be attached here, printed it out of ABS so it doesn't melt from the spindle heat, and then I can magnetically attach this little skirt to it. But since I've basically always been filming or dialing in some recipes, I wanted to see the cut itself, so I have not yet used this dust shoe. But if I do any more like production oriented stuff, I will definitely make use of that. But just kind of get the dust out directly. I mean, sure it's an enclosure, but still you have to clean up the enclosure in the end. And if you're cutting something with like wood and making a lot of chips, it can actually build up and be in the way of the cutter as well. For cutting more aluminum stuff, I'm definitely gonna probably add one of these kind of air nozzle here that you can also add some mist coolant to. The mist coolant will not work with the MDF slats as they will just kind of swell up, but having an air blast will allow you to cut a bit more in aluminum. But if you're not doing that all the time, it's not really necessary. All the tests I did without this, with some of the tests I ended up having to use my air gun directly to just kind of get the last bit out, but those are not settings that I would use unattended anyhow, so I may or may not actually end up putting this piece on, but it's not really expensive if you have an air compressor already. Coming around to the electronics, I'm not going to go into too much detail as I covered it quite detailed in the video about the electronics and nothing really has changed too much. But just giving a quick overview in case you're not interested in the nitty-gritty details. I have a Novuson NVEM controller board here. It's alright. It's a pain in the ass to set up and it has some quirky stuff that I still have not gotten to work. But it is very cheap and has a decent amount of features. I have not really found a good alternative, so otherwise I might have switched. Either they are really expensive or they rely on parallel port interface, which, come on, it's 2022. Parallel port has been dead for over 10 years. This one is using Ethernet, which is quite a bit better, but it's pain to get working. I go into more detail on how to properly set it up in an electronics video. Connected to that, I have the stepper drivers here for the closed loop stepper motors. They have just the step and direction signals coming from the controllers and then have the motors hooked up as well as the encoder signals for them. And they are running on 60 volt, which is provided by this separate power supply here. Up here I have a small separate power supply that just delivers power to the Novuson and all other lower voltage devices as they're not running on 60 volts. I also have like a breaker and some relay up here that make sure that all the high voltage stuff is done properly. I also have here the VFD, of course, for the spindle. That is just how it came and it is hooked up to the VFD output of the Novuson. What also was quite a chore to get properly hooked up is the MPG. It is hooked up directly to the controller, but like each switch and everything of the MPG is hooked up instead of like relying on a USB connection or anything, which means that it directly talks to the controller. So it's even faster than going through Mach 4 or Mach 3. It directly sends signals to the controller, which then go to the motors. So it is really a super tight feedback loop, which is part of why it works so well. However, sadly in the manual, the colors for the wires were not labeled and the wires were not labeled either, and there's like 20 of them. So figuring out how to connect that was quite a chore. This enclosure here is just made out of wood, which is definitely not ideal. I should be using a metal enclosure for the electronics. I did a much more proper enclosure build for my last CNC. If you want to see how to do it more properly, check out that. This is just cheap, it works, and I will be watching this machine all the time anyhow. So do as I say, that is to do. And there's just some fans and emergency off and power buttons here on the outside. For tool probing, I have this little zero switch. However, I, to be honest, have not bothered to set it up yet. I have just been manually touching off the tools, just either by eye or with a feeler gauge. And for X and Y, did the same. But for a Z, I'm definitely planning on properly configuring this. It's hooked up, so it should theoretically just work. And this will allow me to get more repeatable Z measurements. And then for XY, I do not have a probe yet, but if you know of a cheap, easy, reliable probe for XY, let me know. There's some just contact ones that rely on piece of metal, but it's not really precise enough. I would want to be able to flip parts over and probe a bore or something and be able to pick off my origin off of that. But all the ones I've seen so far are either super expensive or don't really worry. So overall, I am very happy with the KillerBee. Considering the price, it has a ton of features, and having linear rails and lead screws on all the axes, none of those stupid belts or V-rollers, for the price is absolutely amazing. Now, it is not as plug and play as a Shipoko, but it also costs less than a Shipoko, and or by now the Shipoko HDM has come out, which is much closer to what this machine can do, but costs a lot more money. It is also quite a bit easier to do still than a DIY build. You don't have to mill or design any of the plates, you just have to assemble it. And if you get the kit with electronics included, there is a manual, and it might not be perfect everywhere, especially in electronics. It just kind of gives you a diagram and tells you, here you go. But there is a manual, there is support, there is a community around it. So if you don't quite want to design your own and build it, but you also don't want to spend a lot more on a fully made one, I feel like the KillerBee just strikes a perfect balance in the middle, where you can build it in a few weeks and pay a lot less than something like a Shipoko. It is of course not perfect, but since it is all based on open hardware, it's mainly open builds, it's very easy to modify. You can just kind of, if you want a bigger one, just get different sizes for some of the extrusions, or if you want to change something else around, it's very easy to modify, and since you built it yourself, you already know how everything goes together. It also definitely has the potential to cut all kinds of wood, plastics, aluminum, no problem whatsoever, and I will go more into that in the second part of this review, where I test all kinds of materials. But for now, I can definitely say that this is quite the workhorse for the price, and definitely enjoy using it very much. So with that said, thank you guys for watching. If you have any more questions about my build, leave them down in the comments, and make sure you subscribe so you don't miss the next part. With that said, thanks for watching, and until next time.